Students, in the last lecture, we have studied the phase rule equation and the different terms which are involved in the phase rule equation, that is phase, component and degrees of freedom. Now, let us consider or let us study the one component systems. Now, the examples are water system and the sulphur system. So, let us start with the one component system, that is the water system. Now, if you see here the water system, see here we use daily, आपण डेली पाण्याचा उपयोग करतो. ते पाणी म्हणजे एक सिस्टीम आहे. काय सिस्टीम आहे ती? आपण भरपूर उपयोग करतो, जसं सकाळी उठल्यापासून रात्री झोपेपर्यंत. ही सिस्टीम काय आहे? वॉटर सिस्टीम काय आहे? लेट अस स्टडी द इक्विलिब्रियम दॅट एक्झिस्ट इन द वॉटर सिस्टीम. So, if you see here, water is a 3-phase and 1 component system. What are the 3 different phases in water? Just now or in the last lecture that we have studied that water can exist in 3 different phases, that is at normal temperature liquid water, when we freeze it below degree centigrade then ice, and if we boil liquid water at 100 degree centigrade then we get the vapor or water vapor. So, these are the 3 different phases, and whatever the 3 different phases are there, that are one component, or whatever the different phases that are there, that consist of one component, and that component is H2O, that is water. So, the chemical composition is H2O throughout. If you consider the liquid water, if you consider the ice, or if you consider the vapor, we get the constituent or the component as H2O. So, let us study the water system. So, you can see in the diagram or if we consider the phase diagram of water system. Now, this is very interesting diagram, you can understand very clearly, or let us illustrate this diagram very carefully, and it is very simple, right. So, if you see here the phase diagram of water system or pressure temperature graph of the system, that is water, ice and vapor, water vapor. So, it is given in the figure 1. So, if you observe the diagram, there are certain features of this diagram, that is the salient features of the diagram can be divided into 3 parts. So, if you see here, no doubt the very simple system is there, that is, if you see the salient features of the diagram, there are 3 different curves. So, you can see that in a colored curves are there, that is OA, OB and OC. So, these are the 3 different curves. Then if you see here, whatever the 3 curves that meet at one point, and that point is known as the triple point, and which is denoted by O in the phase diagram. So, this is the complete TC diagram or the phase diagram of water system. Now, we have studied, we have considered the triple point. Now, the third part of the system, now only one part is remaining, that is of the areas. So, if you see here, there are different areas. So, you can see here the area AOC, the area BOC and the area AOB. So, again if you see here, there are 3 different areas in the system. So, let us see one by one, or let us study the system from the curves. Now, the salient features first of all consists of the different curves. Now, let us study the different curves. So, if you consider the first curve, that is OA, which is nothing but the vapor pressure curve of water. See here, this curve is known as the vapor pressure curve of water. Now, if you see here, it represents again the vapor pressure of liquid water at different temperatures. So, if you go along OA, so along OA we get the vapor pressure of liquid water at different temperatures. Again, if you see here, there are 2 phases in equilibrium. There are 2 phases in equilibrium along this curve. So, you can see the 2 phases which are in equilibrium, that is the water and water vapor. These 2 phases are there along this curve. Again, if you see here, the curve OA terminates at A, means it terminates at point A, which is known as the critical point, and at this critical point the pressure is 218 atmosphere and the temperature is 374 degrees. So, this is very peculiar or critical point where this curve OA terminates. Now, if you see here along this curve there are two phases in equilibrium, that is water and water vapor. Now, let us consider another curve, that is sublimation curve of ice, which is denoted by curve OB in the phase diagram. So, if you see here this curve, that is again sublimation curve of ice OB, represents, or along this curve there are two phases in equilibrium, that is ice and water vapor. So, if you see here the curve denotes at one side ice is there, at one side water vapor is there. Now, if you see here again, if you see here at the lower limit of the curve OB terminates at absolute 0, that is minus 273 degree centigrade, where there exists no vapor. Now, the third curve, if you see here in the diagram, that is OC. Now, this OC is known as the fusion curve of ice. So, ice gets separated from this curve. Again, if you see here the effect of pressure on the melting point of ice, here ice and water, again if you see here, you can see in the diagram, that is along this curve ice and liquid water are in equilibrium. एका साइडला आइस दिसतं, कर्वच्या एका साइडला आइस आहे, दुसऱ्या साइडला वॉटर आहे, म्हणजे या कर्वच्या बाजूला दोन फेजेस इक्विलिब्रियम मध्ये आहेत. आपण थोडं शिफ्ट झालं थोडं इकडं की आइस दिसेल आणि थोडंसं त्याच्या कंडिशन्स मधून पलीकडे गेलं की वॉटर दिसेल. नाउ इफ यू सी हियर again, if you see here, it is noticeable that you can see in the diagram, that is one atmospheric line meets the fusion curve at 0 degree centigrade. So, you clearly see in the diagram, that is at the pressure side you can see here 1.0 atmosphere is shown, and then at this point 1 atmospheric pressure and at 0 degree centigrade. So, at 0 degree centigrade what happens? Normal melting point of ice. This is nothing but the normal melting point of ice. So, along the curves, again three curves that we have studied, that is along the three curves we get the two phases which are in equilibrium. Therefore, if I want to apply the phase rule equation, that is F is equal to C minus P plus 2, then that application will give you F is equal to, now we want to calculate F, that is the number of degrees of freedom. What different degrees of freedom are required for this system? That is F is equal to C. C is nothing but 1, that is a water system is a one component system. Therefore, C is equal to 1 and we have substituted C as 1, and the number of phases along the three curves, there are two phases in equilibrium. Therefore, we have taken P as 2, that is 1 minus 2 plus 2, then that will come out to be F is equal to 1. So, what is the meaning of F is equal to 1? Means to explain the system, water system at the curves, we require 1 degree of freedom. Means we require 1 degree of freedom, that is nothing but if temperature is known, then pressure is automatically known, or if pressure is known, temperature automatically known. So, F is equal to 1 is nothing but it requires 1 degree of freedom. Now, we will say that again the meaning of F is equal to 1 is the system is monovariant, means it requires only 1 degree of freedom. Now, we will consider the triple point, as we have divided the diagram into curves, triple point and the different areas. So, the triple point, now this is triple point where the three curves meet. Why this is known as triple point? Because the three different curves meet at a single point, and that point is O, where OA, OB and OC curves that meet at point O, and this point is nothing but the triple point. Now, see here, this is very important and very typical point where all the three phases are in equilibrium. See here, water system consists of three different phases. Again, at this triple point O, you can get liquid water, you can get ice, you can get vapor also. So, this is very important point where you can get all the three phases which are in equilibrium, and this is the point where we are having the temperature, or this point occurs at 0.0076 degree centigrade and at a pressure of 4.58 mm of Hg. So, see here, this is very typical point, and when this point is observed at 4.58 atmospheric pressure and 0.0076 degree centigrade temperature. So, at this point, this typical point is observing, and all the three phases are in equilibrium. So, if I want to apply the phase rule equation, then F is equal to C minus P plus 2. Then if you see here, component is 1, that is water, that is F is equal to 1 minus number of phases at the triple point are 3. Therefore, 1 minus 3 plus 2, that is the value of F comes out to be 0. So, what is the meaning of 0? So, F is equal to 0 means the system requires no degree of freedom, means the system is non-variant, means at the triple point we don't require any degree of freedom, means we don't require temperature, we don't require pressure, because this is a typical point at 4.58 mm Hg and the temperature, that is 0.0078 degree centigrade. Now, if you see here, the system is non-variant. So, this is the complete explanation regarding the triple point. Now, we will see the different areas. Again, if you see here, the last part of this system, that is where we have to explain the different areas. So, again, if you see here, there are different areas, you can see in the diagram also. So, the diagram will show you the different areas, that is area under AOC. The area under AOC, you can observe it is of liquid water. Now, the area under AOB is of ice. So, you clearly see in the diagram. Again, if you see here, the area under AOB, the area under AOB is of water vapor. Again, single phase is there. See here, area under AOC is simply liquid water is there. Area under AOB is having water vapor and one phase, and area under BOC represents conditions for the one phase system, that is ice. So, again, if you see here, in each area there is single phase. If I want to apply the phase rule equation, F is equal to C minus P plus 2, then the value of F comes out to be 2. So, what is the meaning of 2? F is equal to 2 means if I want to explain the system or water system in its areas, I require 2 degrees of freedom, means I must know pressure as well as temperature, that is nothing but the system is requires 2 degrees of freedom, and it is a bivariant system. So, bivariant system. Next, now see here, very interesting part of this water system, what we have not explained or what we see in the diagram, that is the remaining part. Very interesting part of this system is the metastable system. So, metastable system, what is the metastable system? So, the simple meaning of metastable is nothing but unstable. So, unstable system. Now, this is the complete water system, but when it is unstable, you can see here the explanation. The vapor pressure curve of water AO, see here, the vapor pressure curve of water AO can be continued past the triple point. ट्रिपल पॉइंटच्या आपण पुढे आलो, आपण ट्रिपल पॉइंट ओ आहे आणि तो वेपर प्रेशर पार्ट जर कंटिन्युअस पुढे आलो आपण, that is water can be supercooled. So, if we do supercooling of water, then the supercooled water vapor system is metastable. Now, the supercooling तिथं कर्ववर लिहिलेलं आहे आपण OA डॅश कर्व आहे, सुपरकूलिंग केली आपण त्याची वॉटरची, तर सुपरकूलिंग केल्यानंतर the system is unstable, means the system is deviated from stable position and it at once reverts to the stable system ice vapor on the slightest disturbance or introducing a crystal of ice. So, if we change certain, the system is unstable or it is metastable, and that is known as the supercooled water vapor system. So, this is the complete explanation of the phase diagram of water system. I think you may have understood. It is very simple. If you draw the phase diagram, then you can explain all the points which are involved in the phase diagram. Now, next, the same one component system that we will consider here is the sulphur system. Again, students, you can see the diagram of the sulphur system. Again, this is a one component system, and the different components which are involved in the sulphur system are sulphur liquid, sulphur rhombic, sulphur vapor and sulphur monoclinic. So, the different phases that are shown are sulphur rhombic as SR, sulphur monoclinic as SM, sulphur liquid as SL and sulphur vapor as SV. Now, all the four phases are or can be represented the only chemical individual as sulphur, though the sulphur can exist in different forms, but the single chemical entity is sulphur. Now, if you see the phase diagram of this system, again the diagram is very different from the water system. So, if you consider the phase diagram of this system, then you can see in the diagram, or you can give the salient features of this diagram again in the same manner just like the water system. That is, there are 6 different curves in this system, that is curve AB, BC, CD, BE, CE and EG. Again, if you see here, there are 3 different triple points in this system, but see here, there is only one triple point in the water system, but here in sulphur system there are 3 different triple points that are B, C and E. You can see in the diagram, that is the first one is B, then C and then at the upper side it is E. So, these 3 triple points are there. Again, the different areas are there, so that you can see here 4 different areas you can see here, that is the area which is marked with ABG, again BEC, GECD and ABCD. So, let us see in detail the sulphur system at the curves. Now, again if you see here, just like water system, here in sulphur system there are different curves, that is curve AB, which is known as the vapor pressure curve of sulphur rhombic. Then the another curve BC is nothing but the vapor pressure curve of SM, and curve CD is the vapor pressure curve of sulphur liquid, and the last curve, that is curve BE, the transition curve. So, again if you see here, all the 6 curves, again if you see here curve CE, the fusion curve of sulphur monoclinic. So, and the 6th curve is curve EG, the fusion curve for sulphur rhombic. So, these are the different curves that are there. So, what we should note here is that along each curve, again there are 2 phases in equilibrium. So, if I consider for example curve EG, so you can see in the diagram. So, along curve EG there are 2 phases in equilibrium, that are solid rhombic or rhombic sulphur and sulphur liquid. Again if I consider the curve CE, which is nothing but the fusion curve of sulphur monoclinic. So, if you see the CE curve, along CE there are 2 phases in equilibrium, that is sulphur liquid at the right side and at the left side the sulphur monoclinic or solid monoclinic. So, there are 2 phases in equilibrium. In the same manner, you can see the curve BE, again there are 2 phases in equilibrium, that is sulphur rhombic and sulphur monoclinic, and again if you see here the curve AB, there are 2 phases in equilibrium, that is sulphur rhombic and sulphur vapor, and curve BC, there are 2 phases in equilibrium, that is sulphur monoclinic and sulphur vapor. So, you see in the diagram, all the things are shown in the diagram. So, very important thing to explain the system, water system or the sulphur system is, you must know the phase diagram. Then if you draw the phase diagram, then the things are very simple. So, one by one you can write there. So, if you consider the system at the curves, now very important point, if we observe all the curves, 6 curves, now as there are 2 phases in equilibrium, along all the curves if we apply the phase rule equation F is equal to C minus P plus 2, then whatever the value of F that we get is 1. So, what is the meaning of this is that along all curves in the sulphur system, whatever the 6 curves are there, there are 2 phases in equilibrium to each curve, and thus if we apply the phase rule equation we get the value of F is equal to 1. That is, we can say that the system is monovariant. Now next, so this is the explanation regarding the curves. Now we will consider the triple point. Just like water system, we will consider here the triple point. So if you see the triple point, now if you see here in this system there are 3 triple points, that is the first one is B, another one is C, and the at the upper side the point E. Now these are the 3 triple points where 3 different curves meet at that point. So if you see here the triple point B, then this is the melting point of the 3 curves AB, BC, BE. Now the 3 phases solid sulphur rhombic, solid sulphur monoclinic and solid sulphur vapor are in equilibrium at the point B. Means at point B these 3 phases are in equilibrium, means you can observe all the 3 phases at this point. Okay. Next, as there are 3 phases in equilibrium, if we apply the phase rule equation, then F is equal to C minus P plus 2, component is 1, that is C is having value 1, and P phases are 3 plus 2, that is equal to 0. So what is the meaning of F is equal to 0? Is the system at the triple point requires no degree of freedom, means the system is non-variant. So you may have understood what is the meaning of this non-variant, that is the system requires no degree of freedom. Now the triple point you can see here, the triple point C, again the same condition is there, but the difference is that at point C the curves BC, CD and CE meet. Again, whatever the number of phases that are in equilibrium along this point are sulphur monoclinic, sulphur liquid and sulphur vapor. So again if I apply the phase rule equation, then 3 phases are there, 1 component is there, then we get the value of F as 0, that is non-variant. And the triple point E, the 2 lines, that is CE and BE. So see here the triple point E, where you can see here the CE and BE having different inclinations away from the pressure axis meet at E, where a third line EG also meets. So you can see here that upper line that is joining this triple point is there, means the 3 different curves again meet here at this point E, and again you can see here clearly at the point E there are 3 different phases which are in equilibrium, that is sulphur rhombic, sulphur monoclinic and sulphur liquid. So these 3 phases are in equilibrium along this triple point. So that again if I want to apply the phase rule equation, the F is equal to C minus P plus 2, then we get the value of F as 0. So the value of F is equal to 0 means the system is non-variant. Now the different areas, again if you see here, each area consists of single phase. So the phase diagram of the sulphur system has 4 areas, that are 4 different areas are there, that is area under AB, ABCD, area under ABEG, area under DCFG, so these, and the area under PEC. So if you consider all the areas, that is the labeling also is given, that is solid rhombic, then liquid, again monoclinic and vapor. So 4 different areas are there. Again each area constitutes single phase, therefore if I apply the phase rule equation F is equal to C minus P plus 2, then I will get the value of F as 2. The meaning of F is equal to 2 is nothing but we require 2 degrees of freedom. So means we have to specify pressure as well as we have to specify the temperature also. So this is the explanation regarding the different areas. Now the last part of this system is very interesting part, that is nothing but the metastable equilibria. What is this metastable equilibria? Now you can see here in the diagram clearly the central part of the diagram, that is in the solid monoclinic part. See here the dashed curve of BF is there, that is nothing but the vapor pressure curve of metastable sulfur rhombic. So sulfur rhombic, when it gets converted to monoclinic, then we get the dashed line, that is nothing but the disturbance in the system. So this is a continuation of this vapor pressure of AB of stable sulfur rhombic. The metastable phases sulfur rhombic and sulfur vapor are in equilibrium along this curve, and it is a monovariant system, means it requires 1 degree of freedom. Now again we will study the dashed curve CF. So you can see in the diagram, that is CF or FC or CF, that is nothing but the vapor pressure curve of supercooled sulfur liquid. Now supercooling of sulfur is done, means the temperature is lowered from 120 degrees centigrade, 120 degrees centigrade, and if you see here on supercooling liquid sulfur, the dashed line CF is obtained. Again this, it is the back prolongation of DC. The curve CF represents the metastable equilibrium between SL, that is sulfur liquid, and sulfur vapor. So again if you see here it meets at the dashed curve BF at F, okay, BF at F. Now the dashed curve FE, what is this? The fusion curve of metastable SR. Again metastable SR, that is metastable means unstable sulfur rhombic. So again FE, you can see here the long line, that is FE, dashed line, that is passing through monoclinic sulfur and meeting to E. So this here two metastable phases SR and SL are in equilibrium, and this shows that the melting point of metastable SR is increased with pressure, and beyond beyond E, this curve depicts the conditions for the stable equilibrium, that is SR, which is in equilibrium with SL, as metastable SR disappears. SR means sulfur rhombic disappears. And the last part, that is the metastable triple point, and at this metastable triple point F, so metastable triple point F, again if you see here, this point is at the center where the dashed curves meet, and the metastable triple point F, that is at this point three metastable phases SR, SL and SV are in equilibrium, and the system is a metastable triple point with no degree of freedom. Again see here F is equal to 0 value is there, that is there is no need to specify any degree of freedom, that is the corresponding temperature is the melting point of the metastable SR, that is at 114 degree centigrade. I think you may have understood this one component system, very interesting one component system, that is sulfur system. Thank you.